Okay, so the first question's up here. It's actually not on your packet, but we need to figure this out first to do the second part of it. So this says, what percent of ninth graders are in more than one club? So first of all, I'm only looking at ninth graders. So make sure to not do more work than you have to, right? So how many ninth graders do I have total? Raising your hand. 135. Jonathan, 135, right? So I know, remember, it's part out of a whole. I know my total is going to be 135. Then, Gabby, how do I know who's in more than one club out of those ninth graders?
Why does it say
It's like,
Yeah, I'm doing this question first, then I'm doing that question. And so it will make sense in a second.
so more than one club.
Yes.
Add up 33 and 12.
Cool. What do you get? 45. So I added this question in because you need to do this part of it to get the next part. So a lot of people are like, well, why does it say 180? It'll make sense in a second. And so I know that 45 out of 135 ninth graders in this school are more than one club, right? How do I find that as a decimal, raising your hand? How do I do that? What do I put in my calculator, Mesa? What do I put in my calculator first? 45, right? And then divided by 135. So we always do the top one first. And what do you end up getting, Mesa? Three, repeating. Who can raise their hand and tell me what is that as a fraction, just in general? Me. 1/3, right? So it's a third of it. How do I put that as a decimal? Who can raise their, or as a percent? Gabby. How many times? Good. So what's this as a percent?
33.3%.
Cool. So 33, and I'll just do 0.33%. So that means in this situation, in this school, 33% basically are more than one club of the ninth graders. Right here, they're saying, okay, say there's a whole new school, and in every school is around that percent of ninth graders in more than one club. So if there's 180 students and 33% of them are in more than one club, I'm going to take that 33% and I can write it either as a fraction or as a decimal, so 0.333. I'll just do a couple of them. What does of mean? Multiplication, so times, and then how many students are in this school? 180. So we're trying to figure out how many students are in more than one club. So 0.333 times 180, what do we end up getting? And what would that round to? 60, right? Because the 3's repeating, it would end up being 60. So that means if there was 180 students in this school, 60 of them, based on this percentage, would be in more than one club. If they're ninth graders. Or sorry, 60 students, not percent, because it's 33%. So 60 students would belong to more than one club. So that is a little tricky. I just wanted to give that to start with. But the first thing we're going to be going over, I'm going to go through your packet first, and then through what we're doing today. So the first part, I'm starting with the right below. So when data is displayed as a scatter plot, so you guys know me, sometimes I could be scatterbrained, right? Who can raise their hand and tell me, what does that mean, like scatterbrained? When my mind's everywhere, right? What else can it mean?
Like you're not all over basically.
Yeah, so like basically I can pass out papers and totally forget where they are, and then I have to go do something else, right? And I'm kind of a scatterbrained sort of person. So a scatter plot is kind of dots or little points right here that they could be really, really far apart, like not really correlated at all, or they could be really close together. So that's a scatter plot. And so today we're going to be trying to find two things. The first is called linear regression. And so that means just a line of best fit. So basically the first part is exactly what you guys have been doing in physics, where you guys have to get your data and make your line and do your slope. You guys remember all that in physics? I don't know if you're still doing that. But I'm showing you how to do it on the calculators and making your life a little bit easier. So I'll talk to Mr. Nesney and see if maybe he'll let you do it through the calculator so you can practice with it. So you guys know how to do it by hand. I'm showing you how to do it easy on the calculator. And so the first thing we're going to be doing is figuring out the line, the linear equation, so the slope and the y-intercept. The second thing we're going to be doing is correlation coefficient. And so a correlation coefficient correlation, if I say someone, if you don't get a lot of sleep at night, then you're most likely to be tired during class. That would be correlation, right? It doesn't mean one causes the other. Like, it doesn't mean one necessarily causes something else, which is what we're learning next class, but they're correlated. Who can give me another example, anything that's correlated? Mia.
If you don't study for the milestone, you won't do well.
If you don't study for the milestone, you won't do well. Sure. And so, remember, it's not always that case, right? Some people don't have to study, and you know those people. I was someone who had to study my little butt off, and I would still not do as well as somebody who didn't even study at all. So there's always, I'm that type of person, I'm a horrible test taker. So there's always those situations where it doesn't necessarily cause one another, but they're correlated. Who else can give me an example of something that's correlated? Anything. Nothing? Can't think of anything? Nothing? So, I was a psychology major, and I did this every single day. This is what I did throughout, and I wasn't even a math major. I took 2 math classes. But what you're going to be using mostly is statistics. So, like you're saying, like when I was thinking of the way people think, I'm like, okay, are people from a certain region, do they think of relationships differently? And so that was what my whole project was on.
One let him in.
Sure. Can I talk? Stand out there and I'll get to you. So, correlation, I was saying, does a relationship and where you lived, do they correlate? Is a certain area, do they think of relationships different than a different area? So that was my project when I was in college. So I had to go through all this, but I had to do it by hand and figure out what's the correlation coefficient. So I did this all through college, even though I wasn't really a math major. Even when you're doing like biology, if you guys want to be doctors, you're saying, okay, does a certain drug correlate with how the body reacts, right? And so you'll be using this a lot. This is like my favorite lesson because it's something you're using all through your life. So what we're doing, so when we say 2 sets of data are strongly linked together, we say they have a correlation. The word correlation, so we see that word co, and co means what? Together, right? So if you're co-teaching or your co-workers, means you're working together, and relation. So we're seeing how related or how together are the points on there. Have you guys learned this in 8th grade or no?
We learned about how to.
We have.
I'm
We
gonna
have
learn
ourselves.
a little bit.
Yeah.
So, a correlation is positive when the both values are increasing together. So all the positive means is that they're both increasing together. So that means like when we were talking about the more Elijah practices basketball, the better he will be at free throws, right? Or the more points he'll get in a game. So those more and more, do you guys see how I use those words? Like the greater something is, the greater something is. That would be a positive correlation. A correlation is negative when, like, if I say the longer you're staying up, so the more you stay up at night and don't go to sleep, the less attentive you'll be in class. So say I said like more and less, that would be a negative correlation. So as the other decreases, the other increases. So it's basically like positive and a negative. Does this make sense so far?
Yes.
Okay. All right, so I'm going to go to the next page. And so the closer the absolute value is to 1, what does absolute value mean, raising your hand? I taught me a lot today, Mesa. The opposite, but only if it's negative, right? Just make it positive. So the closer that absolute value is to 1, or if I'm rounding it, if it's to 1, it means it's a strong relationship. So basically, when you're seeing those couples in the hallway and they're going strong, right? Their relationship's strong, they're correlated, they get along, they're compatible. They are a strong relationship, right? Or sometimes it's called perfect. They're saying hi, it's usually we refer to it as strong. So the closer it is to 1, you know, those couples, they have that strong relationship, strong correlation. Then we got those couples in the hallway who are yelling at each other and causing drama and this and that. They are still going out, right? They're still in a relationship, but it's pretty weak. So a weak correlation is if it's kind of closer to 0. So it's less than 0.5 or negative 0.5. So if I were to draw a line, the dots really wouldn't be that close together. They're still all going in one direction. Still going in one direction, but not that close together. These ones are strong because it hits a lot of the line. That one's perfect. Where I can draw a line and hits all of them. So like when you're doing your data in physics, the more your points are towards the line, the stronger the correlation. 0 is that couple that's all over the place and they're about to break up. You don't even know why they're together. They don't even get along. That's my no correlation. That would be 0. So we can't even tell is it positive, it's negative. We can't even tell they're going out. They may not even be going out, right? So that's my no correlation. And so I kind of like these notes a little bit better than your foldable, so that's why I'm going with this. So correlation coefficient describes the amount to which the x and y's are correlated. So +1 is perfect positive. -1 is perfect negative. All the negative and positive mean, negative means it's just going down. Positive means it's going up. The number, the absolute value of the number is what tells you if it's weak or strong. So let's try a couple of these out. So this one, is this a negative or positive? Is it going up or down? Down, right? So we know it's negative. And so if I were to draw a line, is this couple going strong or are they kind of weak? They're all over the place. So they're still, even though it's not perfect, it's still strong, right? They're still close together. We still see them hanging out and getting along, right? So this would be closer to like -1. So it's not going to be exactly -1. It'd probably be like -0.9 or something. But they're still pretty strong. Rather than this one, see how the points are going down? Would it be negative or positive slope? Negative. And see how if I were to draw a line, they're still dating, but they got little issues going on. So would this be weak or strong? Weak. So it'd probably be around like -0.48. Just making these up. So if it's under 0.5, it's kind of weak. Then right here, we got, is that positive or negative?
Positive.
Positive. And I would say it's pretty strong. I would say it's closer to like 0.6. If I rounded it, it would be 1, but they're not totally compatible. They're not like, oh my God, couple goals, relationship goals, right? That would be perfect. What about this all over the place? That's none, right? That would be like 0. I can't even tell if they're dating, right? So that's correlation coefficient. Remember, correlation coefficient is not slope. They're two different things. Yeah. Good question. I'm going to show you how to get those numbers. And so that's what I'm showing you now. So we're going to go to the calculator cheat sheet, that little page that you have. And I'm going to show you on the calculator. I don't need you to do this by hand. So I'm showing you A, how to do Mr. Kinesi's work on the calculator, doing that line of best fit, and B, how to get your correlation coefficient. It's on this little, does everyone have this little piece of paper? Does anyone know? I have a bigger version, and you could copy it on a smaller version. I don't know if this will fit. If anyone has a big notebook. Does anyone else need one? And so if this doesn't fit in your notebook, we can cut it a little bit to make it work. Okay, so just be careful. You only need to do this once. And so you may not even need to do it at all. But this is just seeing, we're turning basically on the calculator. So the first thing you do is fill this in, you press second and 0. And it should look like this, a little catalog. And you're scrolling until you see diagnostic on. So you're scrolling and you only need to do this once. Like usually the class before you has already done this, so you don't really need to do it. It's only if you really reset your calculator. So before your milestone, your calculators will be reset. So you will have to do this. And then, but don't do this every single time. That's a lot of wasted time. Then you should have a screen. Once you click enter on it, you should have a screen that looks like this. And you just click enter until it says done. So it should look like this. So you're clicking on diagnostic on. You're clicking, it should look like a screen like that. You're clicking enter and it should say done. That's a little hard to see, but it's right there.
That's all the way down to.
Yeah. And so you only have to do this like once. Basically, you probably won't have to do it in here much. Just like when you go to your milestone, you'll probably have to do it. Does everyone have that down? Or at least you're going to do it with me too, just to make sure you get the same stuff. All right, next we're going to do is right here. So this kind of looks familiar. So you click Stat and then select Edit or Enter, and you're typing your X data into L1 and your Y data into L2. If you need to clear the numbers in here, all you have to do is highlight this. Don't click Delete, click Clear and Enter, and it will clear that. Make sure you don't delete L1 and L2. And so type the numbers that are on your paper in your calculator, just so you know that you're doing it right. And remember, step 1, now for the rest of class, you do not have to do it.
On this paper?
Yeah, so type those numbers in. The numbers that are on your paper. And so these are the points. Technically, this is 5, 1, 7, 5, 8, 4, etc. These are my points. Last thing you do is you go to Stat again. And this should look familiar, Calc. And when we did the min, max, all that, that was step 1, right? This thing right here. But we're not going to that anymore. We're going to 4, where it says linear regression. This is linear regression. And you're pressing Enter. And then you're just scrolling to calculate. I don't know why it's not on here. Scroll to calculate. Click Enter. And so after you do that, you should see a screen that looks like this. If R square and R are not on your calculator, that means you forgot to do diagnostic on. So you can always try it, and if you don't see that on your test, then you know, oh, shoot, I have to turn diagnostic on. And so this is how you get the line of best fit. So you can do this in Knesnit's class too. All you have to do is it's in y equals mx plus b, right? And so instead of m, they're using a. And so a is your slope. So this is your slope for the line of best fit. The b is your y-intercept, and we can do this with any function. I'll go over it more when we're reviewing for your milestone. That b is your y-intercept, and see where it says r squared? You're not going to ever use the r squared in algebra 1, so don't even pay attention. And r is your correlation coefficient right here.
Absolutely.
Did you do diagnostic on? What does it say on your calculator? Oh, okay, great. So, for example, right here, Alana says just A and B on her calculator, right? And so that means you have to do diagnostic on. So like that first part of it, this thing, you maybe didn't click enter until it said done. Right here. Let's see a second. Settle on. Are you trying it on your calculator? And then we're on the last part. Stat.
Oh,
There you go. So she did diagnostic all. Make sure you scroll to diagnostic. And now it's that. So. Okay. And then scroll to calculate. Click enter. Let me just finish my thumb. So when they're asking for your IXL for so there's this is the rest of your IXL. This is it for the unit. Your test is going to be on Wednesday, next Wednesday. So you have Monday review and then Wednesday.
What test will be on?
For unit 5. So it was pretty short lesson. There was only 5 lessons, so it's really not much. But for this, This is your last IXL. So this IXL was KK13. And so it's just telling you to give me this in slope intercept form, and they want you to round to the nearest 1,000. And so how many zeros are in 1,000 in general? 1,000? 3. So that means they want you to go to the third decimal point. So what is your slope here?
0.5.
Good, 0.522. How would I know if that last 2 needs to round up?
If the four is
Good. Yeah, if that number is 5 or greater, right? And so because it's less than 5, I don't round up, it stays the same.
you have an X.
No, they'll have that on your, you're just filling in A and B. And then B is your y-intercept. They want you to put that in slope or in 1,000 too. So how would I write that one?
0.286.
Good, 0.286 because that 7 rounds to 5 up to 6. So that's your equation in slope-intercept form. So when you're doing Kniezny's labs and he wants you to get it in slope-intercept form, you can just do this and that will get you the slope and y-intercept. And that's more exact than doing it by hand. And then the last part is your R. This is KK13 and 10, or sorry, KK11 and 10, is your correlation coefficient. And they want you to round that to the nearest 1,000 too. So what would this be?
8.02.
802, right? And so first of all, is this a positive or a negative correlation?
Positive.
Positive, because it's a positive number. So if it was negative, it'll have a negative next to it. And so is this a strong or weak correlation?
Strong.
Strong, because it's closer to 1, right? So this relationship's going strong. And so that's what that tells us. It tells us if the dots are close together or far apart. And so do you guys understand the difference between the slope and the correlation coefficient?
Yes.
Because I got confused about that myself, so I want to make sure I'm making it clear. Okay, so what you're going to do, you guys have the choice. If you guys want to work on the 3 IXLs, the first one is just matching correlation coefficient with the graph. The second IXL is this purple part coming up with the correlation coefficient, so just doing it in your calculator. And the last one is doing this in slope intercept form. Yeah, you can, if you want to put in headphones, we'll see. Yeah, 1 second though. Or if you guys want to do stamps, I have my answer key up here. If you'd rather do the stamps, you need the agency grid up. But last 15 minutes of class, we are doing our deliverable. I need to make sure, I sent out a reminder a couple times. I need to make sure that you guys filled this out. Did everyone fill this out? So if you didn't, please make sure you do it by the last 15 minutes. Real quick, I'm almost done. Did everyone fill this out? Because you are getting an agency grade and you do need to fill this out in order to do our last deliverable for today class.